pit. That's some deodorant here. Hey Austin, how's it going, dude? What's going on, man? Welcome in, welcome in. I am stressing, man. Let me tell you, I am pretty stressed. For this interview on Thursday. I honestly should have just made it for tomorrow, just got it done. Or maybe even today, but I just am so, dude, I haven't been able to think about anything else like all day. And it's like really been stressing me out bad. It sucks, man. Hey Aurora Sore, how's it going, dude? Welcome back. Thanks Austin. Dude, I've just been really stressed. I just don't know what they're gonna ask. I'm just nervous. You know. All right, so I wanted to go over some of the kind of like basic string manipulation problems that we, did on Leet code. Some of the more earlier problems. So that's what we're gonna do here. So let's solve a two-sum again. Dude, Tim, dude, I'm so nervous, man. Like I'm really stressing, like bad. I've just been sweating all day. I can't get it out of my mind. It's just like I have this like pit in my stomach. I feel like I'm gonna puke. It's just like I'm really stressing and struggling here, guys. Like I handle stress really well in terms of like just like like work or things like this, but like evaluation type of things, like stuff like this just really, I don't know why, it just gets me super worked up. I think it's because I honestly think it's because I just want it really bad. I think it's because I want it really bad and I'm scared to do bad, and that's what's making me really nervous. Hey Avinash, welcome back in, dude. Yeah, I have an interview. We have an interview for a software engineer chemist position for a company, and we did a screening with the recruiter, and we did a take-home problem, and now I have to do a live coding interview, and then if I pass that, I have to do an in-person like panel thing. So I'm really stressing you guys, let me tell you. Okay, so I think for the plan for today is I want to go back through and work on some more of the more basic, more common Leet code problems like two-sum, palindrome, all those, these types of problems, just to get some more, just hit those one more time here, because we haven't done these ones since we first started doing Leet code. So I want to come back to these and make sure we're doing them. Okay, so for two-sum, given an array of integers, nums, and an integer of target, return indices of the two numbers such as they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answers in any order. Each input will have exactly one solution. Okay, so with this one, we can use a data structure of a set to place, we can take the difference from the target for every value, And if we use a data structure of a set, we can get O of 1 access to that data structure on references and check if the difference value between the numbers and the current value is in the current set. And if it is, then we're going to go ahead and take that number that we're on. Right? I believe that's how we solved this one. So we have n is equal to the length of nums, and we have like scene vals is equal to some empty set, right? Or I think we have to call it like this probably. So if I say for I in the range, let's loop over the array of numbers accessing the I for the index values of n, right? If nums, so let's take a difference of the number right off the bat. So this will be nums index of I. So target less numbers index of I, right? We can say target is 9 and we want to get two indices that add up to that 9. So we want to go access into our set to get out a value. Yeah, that'd be great, Avinash. That'd be awesome. Right, so you guys, we have to use a set here. Target minus nums index of I equals is diff. And then if the difference is in our set, yeah, if diff in scene, we're going to return a list of diff and what? Nums index of I. Thanks, Tim, Mr. Tim. You guys are awesome. So if the difference is in scene, it's meaning we have computed a value. We have seen a value previously that would be the difference too. So we have a valid to sum. So then what we can do is else, right? We don't even have to say else here. We can just say, because we're going to return those two indexes. But we need the indexes, right? So actually, we want to return maybe instead of a set, we should have it be a dictionary with the indexes being the values, so we can get access to the indexee of what it was. So let's put here, make it a dictionary actually, right? And then let's go, we want to access diff scene of diff, right? Because we want to go into the scene dictionary here, grab the difference key, the value associated with the difference, which is the index that we're going to save, right? And then we'll get, this will just be I, right? And then else, like we need to add to scene. So let's go scene. We'll say diff, or no, sorry, scene nums index of I equals to I. And then I guess if you don't get one, you return none. So let's talk this through. So we're going to loop over the range of our values, accessing the indices. We have a difference dictionary here where we have keys being set up as the actual values themselves, and the values of these keys being the indexes which they reside. So for I in the range of n, we take the difference between the target and the number. If the difference that we calculated is already a previous value we've seen, meaning that we can take that value plus the current value to get to target, right? Then we can just return scene diff, or right, scene dot, we can do scene get diff, right? Right, even we could do this, and then if it'll be in there, right, because it's in there. So I mean, we probably can just reference it by this syntax here, and then with I. If it's not in there and we don't return it, then we're just going to add to scene the current value, so like 2, 7, 11, or 15, and then save the value of that key as I. So let's try to run this. Oh, let's go. Let's go. One down. One down. That only took us like 5 minutes. I mean, yeah, we've done it before, but I haven't solved this problem for a few months, probably a couple months. Okay, not bad. Not bad, not bad, not bad. Can we get some hearts in chat for that? To some? If you guys are practicing your Leet code with me, let me know. Hey, Eduardo, welcome back in, dude. Oh, I'm not streaming on the Twitch. My bad. No one told me, you guys. Come on. No one told me we were streaming on the Twitch. All right. Let's keep it rolling. Let's keep it rolling. Let's do valid palindrome number. Given an integer x, return true if x is a palindrome and false otherwise. All right, well, we'll do threesome after this, Tim. We'll give it a go. For you. We'll have a threesome. Pause. Pause, pause, pause. Okay, so we want to detect if this is a palindrome, right? So, interesting. So for the number, I mean, we could easily just go over this number. Let's just do this, right? So let's say, well, you can't take a length of a number, right? You have to convert it to a stir. Yeah, you can't take a length of a number or an integer. So we have to convert this value to a stir. But what if we don't want to convert the value to a stir? Interesting. Do you have to convert the value to a stir? Could you solve this without converting the integer to a string? Ooh, that's a follow-up. Okay, so let's try to do it that way, guys. So if we have an integer and we want to determine if this is a palindrome, we need to somehow evaluate the back of the string against the front of the back of the integer against the front of the integer, maybe with bit manipulation. So if we bit shift this, well, with just negatives here. Interesting. Palindrome number. This one's been a while, boys. So if we have an integer, we want to do it without converting to a string. Okay, so what kind of operations we have? Like bitwise operations that we can do. If we pair it up against itself. Okay, so if we pair it up against itself with bitwise, is it XOR? and we get 0, it's a palindrome. Let's see here. Let me say return x Okay, so let's first, no, I don't want to convert to a string because I know how to do the string one pretty easily. We can loop it or we can slice if we wanted to. We can to save memory. We could loop to save memory or we could slice to use memory. But if we want to do it with an integer, what do you guys think? What do you guys think? What do you guys think? If we want to do it with an integer. Okay, so think my integer property. So we obviously can do some sort of math operation to this, but so maybe we can, okay, let's do this. Let's get the remainder. So if it's negative right off the bat, it's not going to be right. So if it's positive, so if we pop off the remainder by dividing by 10 every time, and then compare that to the original value, that'll give us the we can take, if we divide by 10 each time, that'll give us, right, the remainders. So this is a remainder of like 21, leaving off that 1, and we can take that 1 and put it here. So let's do that. Let's go like this. Let's get the modulo of this. So let's say while x is greater than so let's actually make a copy, I guess. Copy is equal to x while copy is greater than 0, right? Maybe it might have to be equal to 0, but we'll check that in a second. So while copy is greater than 0, let's get the remainder of this. Let's say remainder is equal to copy modulo by 10. This will give us, so if this divides by 10, the remainder it's going to give us, let's go ahead and print remainder here. Well, so if we say you get 0.1 left over, you divide 12 evenly, you get 0.1, which is, so let me open up my, let me do this. Okay, so we get remainder of 1. Yeah, we're getting the values individually. Okay, let's build the, let's do it. Okay, so let's say while copy is greater than 0, we're going to say copy is equal to x while copy is greater than 0. Let's get the remainder is equal to copy to modulo by 10. right? We'll just reduce this down once in magnitude to pull off the values here. And then we're going to build a string, right? We're going to build a string is equal to actually, because we need to do this. So let's set magnitude is equal to 1 here. And then what we're going to do is we're going to set remainder. So we'll say diff is equal to the magnitude times the remainder, right? Then we're going to increase magnitude by 10 times its current, right? And then we're going to, so we calculate the difference, and so now we need to set, or actually I guess copy will become this. And so we'll say copy is equal to diff. Copy becomes the remainder times magnitude, so that gives us to 1. No, so that wouldn't be actually, no, we don't want to do magnitude times remainder equals difference. We want to take, that gives us 1. Copy equals to copy less diff, right? We need to take the difference of magnitude away from the current copy. So what's going to happen is it's going to pull off the 1, right, with this remainder. Okay, it's going to pull off the 1, and then it's going to calculate 1 times 1 to give us 1. We're going to increase magnitude by 10 times, so now it's 10 for the tens place. And then we set copy to copy minus diff. So now copy will become what it was originally, so it's 121 minus 1 becomes 120. So now when we take this, we're going to get a remainder of 2 back, right? And then what we can do is we can build this string, right? Or actually we can just add these together, so this gives us the ones place. So could I actually take the magnitude somehow and determine can't take that length. So let's set, we get the remainder because that's the remainder of 1. We calculate a difference, which is magnitude times the remainder, right? Copy them becomes 120. We calculate a remainder divided by 10, right? It's just going to be 12. Right? So if we're at 12, does that give us... Hey, Amon, how's it going? So actually let me print really quickly. I want to see this value. Let me print 120 modulo by 10. Does this just give us 0 back because it goes in evenly? Yeah. Okay, good. Okay, so I just give 0 back. Divided by 100. Oh, so let's do this. So if we instead set the magnitude initially equal to 1, let's do, this is going to be 10 times the magnitude, right? And so now this will be to 120 divided by modulo by 100 will give us, we'll take the 2 away. Yeah, we'll take the 2 away. We'll increase the magnitude by 10 times. And then set copy equal to the difference. So we need to add these values together. So we'll say result is equal, or rev is equal to 0, and we're just going to we calculate this remainder. So let me just do this, take this down. Let me just put this here and then just get rid of this. So then we need to save rev plus equals to the remainder. Return rev equal to x. Return rev equal to x. Okay. Let's see. Oh. We'll just call this rev. Let's take it back. And return true there. Okay, so in this test case, false. Okay, so return if rev is equal to x. Okay, so we doing something wrong here. We got 121 is false and 10 is true. So for 10, we're going to divide this by 10. This is 0. So x is 10. Rev becomes, remainder is 0. Copy goes down by 0. Okay. So we'll have to put here if rem greater than 0, let's break. If the remainder, sorry, is 0. So the 121 is going in, which is greater than 121 is greater than 0. So we do 10 times 1, which is 10. 121 modulo by 10 gives us to a remainder of 1. This doesn't happen, so we go into here. So we update 1 oh no, rem times magnitude. No. So we need to take the remainder, which is 1, times it by the magnitude. and update rev. So this will build, now this is just going to build the same string, right? Because this is just going to build 10 times 1, which is the tens place. Oh, the ones place. So magnitude has to start out at 0, because we have to go to ones place. So 10 times the magnitude, modulo, so divided by 0, 0 will just give a remainder of 0. We don't break here. We calculate rev plus equals rem, which is 0 at the first. And we increase this by tenfold. Maybe not. I don't know. We have to... Hey, technical, how's it going, dude? So 120 reads as 120 left, right. Okay, so if I modulo... Let me get my pen out. If I'm trying to do this without converting to a string. Right, so if I modulo 121 modulo by, oh, let's just do not by 10, let's just do by magnitude and start magnitude off at 1. So now you modulo by 1 gives you reduce copy. I wish I had a, let me see. I'm just gonna type in here, no, I'm not gonna type in, I'm gonna type in 1, 2. A modulo of 1 does what again? Turn 0. Yeah, 0. Okay, so it returns 0. So if we have a modulo of 1 here, this returns 0. We update. Copy gets reduced by 0, and this is just infinite. So we have to stay by 10 here. And then we reduce by magnitude, so we start off, we reduce by 10. Now we're trying to solve the follow-up here. We don't want to cast it to a string. Yeah, it's way easier as a string. It's really easy as a string. Okay, so if we modulo by 10 on 121, this gives us back 1, right? And then we want to take this and multiply it by... You can't take the length, though, of an int, right? You can't take a length of an int to get like how much magnitude it has. Yeah, you can't take the length of an int. Okay, so if that's the case, let's do this. Can we import? Oh, hold on. I'm so dumb. You can easily find the no, you can do, wait, hold on, what was I gonna? But the thing is that I want to take the number, right? If we modulo by 10 here, that gives me 1. And I want to take that number and multiply it by I want to take that number and multiply by 100. So I can get the first number. One plus 20. So that'll take us to 120 divided by No, we're not going to convert to stir. Oh, my bad. I didn't see the Twitch chats. Hey, Loco no, Lock on go. Sorry. Hey, Dev God. Hey, Bullmaster. How's it going, you guys? Welcome in. We're practicing for my interview coming up. Not doing good on this one. We can solve this one with the string pretty easily, right? I know how to do that one but we're trying to do this one with math here. But I don't want to have to import math and take a log base 10 to figure out the length. But what is the log base 10, right? A log base 10 is just 10 to what power gives you the current magnitude, right? So we could actually raise our magnitude by a power of, let's do 10 to the power of the magnitude, right? Starting at 1. So this would take, we reduce copy and then increase magnitude by 10 fold. So what would this do? Right, so this would take 10 to the power of 1 would give us 10, right? Which would reduce copy, giving us 1. And then we would add this to the reverse. Right, we add it to the reverse. Yeah. But that would technically be just building the string back up from its original form. So I would need to multiply the 1 by, because I'm pulling off this 1. So I would need to multiply it by 100 to get to the 100. Then I would take the 20. I would get the 2, multiply that by, and then multiply this by 1, by 10, and then multiply this by 1. It's chemistry related, so it's like more like chemistry, scripting, kind of stuff similar to my projects like SpectroSim, ChromaPlot, that kind of stuff. My take-home problem was very similar to kind of like a lot of the stuff we did in SpectroSim. Okay, so we take this just builds the same string, I'm pretty sure. Right? Which outputs true for this. Yeah. This is just building the same string. So I need to figure out, so I could use a second while loop to just figure out the magnitude by reducing this down. So if I compute a remainder, gives me a remainder of 1, but I need to compute, so 10 modulo 10 gives you 0. If you ever get 0, do you just break? Do you just break? I don't think that's going to solve it, though. No. So I could do this. This is going to give me a remainder of 1. Which gives me 120, and I can increase a count to 1 to count how many times I'm doing this loop. So the first time you would multiply it by not power, let's just do 10 times 10. So we can just increase magnitude actually by 1, and then to keep this power, right? Or multiply and increase magnitude tenfold, either one, right? How do you go live on my Mac? Just with OBS. One to 10 plus 2 to 100 plus 20 plus 1. Oh, shoot, man. Magnitude. So the thing is like, if I did 10, that would reduce down to 2. If you modulo by 10, makes your range 0. Plus 1. 1. 2. We could find the length by anyone have any thoughts to point us in the right direction here? Anyone have any thoughts? So right now I'm just building the array as is. Like I need to multiply this remainder by the length and then decrement the length down. But to build it in reverse, I need the 100. Wait, no, maybe I have it. Don't really need length. Yeah, it's just how many interactions you, exactly, right? So then, yeah. So let's just throw length out the window then, because I was thinking of using the length, right, to use the magnitude down to count how many, and then use the value of the length as my multiplier here. But so if I say copy times, so this is going to say 121 modulo 10. This is going to give me a remainder of 1. Okay, now if I want to build the string in reverse, I need to multiply that value by 100. So where can I get the 100 from? No, Abdul, we can't turn it to a stir. We're trying to solve it with the contingency of no stir. No stir, no sir. Right, and then that gives us, and then we can calculate 121 less the 100 gives you to just 21. Then you modulo by, oh, okay, so we just need to modulo by 1 at the start. To the power of, we start magnitude off at 0. 10 to the power of 0 is 1. No. Yes. 10 to the power of 0 is 1. Right? So then this will take copy modulo 1. Right? Am I tripping? I might be tripping. um... Wish I had my calculator from college still. Was this one? Yeah. So if we have this be 0 to start, and if we do copy modulo 0 gives you copy modulo 1 would give us 123. Bad. Yeah, each digit's a new power of 10 in a way. Yeah. Dang it, dude. Why is I struggling so hard with this? So if we take 10 to the power of 0 is 1. If we take 121 modulo... Oh, what if we do it the other way around? So what if we... Let's print a couple things. Let's print 121. I'm always so bad at predicting what these modulos will output for some reason. I don't know why it always it wrecks me. Okay, just 0 and 1. No, that's not really what I wanted to do either. Thought it maybe would give us... Okay, so let's think. Come on, Mike. Come on. You got this. So we can do 10 to the power of x, right? And we can get the ones place. I need to multiply that by 10 to the power of 10 to the power of 2. See, I need to multiply it by 10 to the power of 2 at the start. Yeah, it just gives you the last digit of the number. So we're getting, yeah, that's exactly what we've been doing. We're getting the 1, but I need to multiply that 1 by the max magnitude of this number, which is 100. And then I need to add that to the rev. But where can I get the 100? If I don't have a power of 2 to work on initially. I don't have a 2 at all in this problem. What happened here? Right? So I need to modulo. If I modulo by 10, right? This is going to give me, in this example, this gives me the 1. Remainder is 1 here, okay? I update rev to be remainder, but I need to multiply remainder, right, by okay, so you have the remainder of 1. You just update this. You just copy it down. So let's just compute this. Temp is equal to 10 to the power of the magnitude that we're currently on. Okay, so 10 to the power, which is 1. We're going to put temp here. Okay. I save temp here. So if I do times plus temp here. So now on the second pass, I'm going to get temp is going to be 10 plus the remainder of 12 for 2. This is going to be times. So I take the remainder, which will be 1, multiply it by temp, which will be 1, and add that to rev. Then we're going to take 20, or take 2, right? This is going to give me 2. Temp is going to become, magnitude goes up. Copy is 120 divided by 10 gives me 2. And then I say rev plus equals 2 times 10, 20. Increase the magnitude by 1, set copy. Now I don't even think we need this really. Well, maybe we. Right? Okay, so we're computing at 10. So temp is going to be 1. Modulo by 10 to the power of 1 gives us 1. 10 to the power of 0. Gives you 1. So let's start magnitude off at 1. Yeah, we have to start at 1. We'll do this. So 10 to the power of 1, right? Which gives us to 1. We take that value, we multiply it by 10 to the power of 1. No, so magnitude and did we need a count variable to start off at 0? Or do I have it at magnitude minus 1? So we need to take the 1 and keep it. So what do we have to, but we also need to take the 2, multiply it by 10 to the power of 1. So that means our magnitude has to start off on 0, which would mean we would modulo by 1. Ten to the power of 0 is 1. That would be for temp. So modulo by 1. No, we don't want to do that. So if we have magnitude start at 1, we multiply it, so that gives us to 10 to the power of 1, which is 10. That would give us the 1 back. So then we need to multiply it by remainder of 10 to the power of 2 times 10 to the power of 1 would give us 20. And then 1 times 10 to the power of 2 would give us 100. Zero times 10. Oh. Remainder times let's get rid of this temp. I don't like this temp variable. Let's put, so we're going to do it 10 to the power of magnitude. And then we're going to do this to multiply this by remainder, which will be 2, times power so let's do remainder times 10 to the power of mag less than 1. So now you get 0 here to an update mag. Okay, so let me write this through. Stop being lazy. Write it out. Okay, so I'm going to, in my first pass, on my first loop, number 1, I have mag equal to 1, rev is equal to 0. I'm going to go into the copy. Rem is going to equal to copy, which is 121, modulo 10 to the power of the magnitude. So 10 to the power of 1 is 10. So we're going to get a remainder of 1. We're going to take rev and increase this by rev plus equal. Rev now becomes, from 0 becomes 1 plus 10 to the power of 1 minus 0, 1 minus 1, which is 0. Ten, 1 times, okay. Then we update copy to be 121 minus magnitude, which is going to be 1 times the remainder 2. So this would be this same expression here. Ten to the power of 0 gives us to 1 times 1. Oh my gosh. So we're going to calculate a remainder equals to the current magnitude, no, sorry, remainder equals to copy modulo 10. Get a remainder of 1. Rev equals to, plus equals to. So if I say count equals to 0 rather than rev, and then I say rev equals to the remainder times 10 to the power of the count, 0, then I go count plus equals 1 to increase the count. So now this goes up to 2, 10 times 2. we're not updating copy. Whoops. So we need to do count plus equals. So let's do copy. It's going to equal to. Got to reduce copy down by. So let's calculate out a diff. I guess that'll be easier. Equals to this. Let's set rev plus equals to diff, and then copy equals to copy less than diff. And then increase the count. Let's do infinite loop. Copy less than diff. So we're going to get the remainder of 1. We're going to multiply that by 10 to the power of count, which is 0. And so that'll give us 0 for diff. Okay, so then let's make. So we have to have count start off at. The power of 0 is 1. Count the power. Oh yeah, whatever. So then actually. No. So now we have. Why isn't this working? So this has diff 10 to the power of 0 is 1. 1 times 1 is 1. Diff is 1. Rev goes up by 1, and copy goes down by 1. Count increases. We get the 2 on this next pass. We do 2 times 10 to the power of. Okay, so this is where we're going wrong here. We need to have 2 times to the power of. Power of 1 is 10. 2 times 10 is 20. Increase that to diff. Reduce copy down by 20. That'll take us to 100. This takes diff. This makes copy 0. So we need this to run while it's less than or equal to 0. Or greater than or equal to 0. No, copy becomes 0 here, then we're done. Right? No, we're not using stir, y'all. We're solving the follow-up. You're saying x divided by 1,000 equal to considering number x of length 4, x divided by 1,000 has to be equal to length equal to x modulo 10. 123 floored by 10. Yeah, you just divide by 10, and then whatever's left over, and then you get back to 3. So why am I getting an infinite loop here? Am I getting an infinite loop still? Yes. Okay, so copy is not going down for some reason. Why is copy not going down? 10 to the power of 0 is 1. 1 times 1 is 1. Copy goes down to 120. On the next loop, copy is 120. Remainder of 2. 2 times 10 to the power of 1 is 20. Increase the rev by 20. Decrease copy by 20. On the next pass, we're at 100. Rem equals 0. Okay, so that's why. So if it's 0, so if rem equals to 0 here, we have to do something at the start. We have to, if it's 0, right, meaning that we, 100, we're going to take, but I don't have this value, right? Oh, we're just going to increase rev plus equals by copy and then break, because that is the value itself, 100. So I think that solves the problem. Ah! Okay, so now we're this is true. So then this goes up by 10, and then this gives back. Ah, crap. Right, so, yeah, exactly, Brandon, right, Marius? Yeah. So now, though, on the example of 10, this is getting 0 here, right off the jump. And then if we increase rev by copy and break, then this returns 10 equals 10. This problem sucks. I'm always bad at these base conversion problems. I just don't. Okay, so I'm got a copy which is 121 modulo by 10 to the power of 0, which equals to 121 modulo of 1. I don't want to do 10 to the power of 0. I just want to do, no. 121 modulo 10 equals to 1. I want to take the remainder, add to it the base. So this is a base of 0 for the ones place. 10 remainder is copied of 1. 1 times 1. 1 times 0 plus 1. Right, we need to have to compute the base. This has to be to the power of count. I think that's it. Oh! X equals 1. So if remainder is 0, do we break and then do the evaluation, which is 0 against 1? Maybe not. No. So we have just when we have x equals to 1, right? I'm not gonna. We're working through the problem. I don't know why you're getting frustrated. Ruin your message. It's like we're not in any rush. It's part of the learning process. So, right, we're going to 121. We're moduloing by 10. This gives us a remainder of 1. We're going to then take this number, add it to 10 to the power of 0, which is 1. We don't want to add it to 1. To 0 times 10. Count times 10. Oh, let's do this to the power of 10 times 0, 1. 10 times 0, 0. So you just have to keep it at 0. So 10 times 1 is 10 to the power of 1 is 10. No, I don't want to multiply by 200. I want to just take the remainder, 1, add it to 10. So I need to add it to 0 because I need to keep the 1. So how can I take this 10 and make it a 0, but also have it be 10 in the next round and then 100 in the next round? But I need it to be 20 because I have to add 10 times that number. Yeah, so this has to be multiplication one times 10 to the power of 0, which is 1. Okay, that keeps it. Now in the next pass we get 2. I want to multiply that by 10 to the power of 1, which gives me to 20. And then on the next pass I want to multiply that by, I get the 1, I want to multiply that by 1, 10 to the power of 2, it gives me to 100. But that modulo by 10 equals to 0. So copy never decreases. Let's compute the rev here. So then let's update the rev. If, now put the conditional below here to say if the difference is 0. No, if you update the rev to 0, this becomes 0 here times this. So that's why this has to stay plus. So that we can just add 0 plus 10 to the power of 2, which would be 100. But on the first pass, it'd be 10 to 0. 1 plus. See, then it would be 1 plus 1. And I don't want to do that. I don't want to do 1 plus 1. I want to do 1 plus 0. Oh, okay, so let me do this. Let me take the remainder, which is 1, plus 10 times 10 to the power of 1. So this has to be 0 at the start, so it's 0. So I do count. So I do count times remainder plus, so this would give me 0 on the first run, plus 10 times to the power of 0, which would be 1. Then on the next pass, I get 10, but that's going to multiply 0 by everything. So even on a 3 on the ones place, that's not going to work either, because then it's going to add just 1 to that value there. Bro, we're not converting to a stir. Hey, Imbia. How's it going, dude? Thanks for coming back on Twitch. Appreciate you so much being here. Welcome back. Welcome back. All right, so then... come on. I feel right there. Okay, keep working through it. We got to keep going. Don't give up. Don't give up. Already blew a lot of time of our study time. Whatever. It is what it is. If we fail the interview, we fail the interview. That's life. Okay, so we compute a remainder. We just get the 1. I need to add to the 1. I need to add 0 to it. And then on the next pass, I need to take 2 and add... So if I actually, let me take 1 and multiply it by 1. Take 1 and multiply, then you take 2 and multiply it by 10. And you take the 1. Right, and so then I have to take, that means I have to compute 2. See, the thing is, I don't really know what to do for the instance where you get the 0 for the remainder. Because if you just add the copy at that iteration to rev, then you're adding copy. Take a seat back in your clamshell. What happened to our tunes? But if it's 0, my loop breaks. Compute the remainder. Compute a remainder. Let's add the remainder. Times 10 to the power of the count. Right? And then let's reduce copy. So we say it's 121 less than the current rev, and then 1. And 100. 1 breaks. So we have copy modulated. This gives us 1. 1 to the 10 to the power of 1 is 2 is just going to be 1 times 1 gives us 1 to rev. 121 less than rev, which is 1, is equal to copy. Okay? On the next pass, we get 2 for remainder. 2 times 10 to the power of, oh, we need to increase count. No way, still? Thought that might have been it. Still infinite. I always get infinite loops. I'm so bad at increase count. $121 less than rev, which will be 1 on the first pass. On the next pass, it'll be 2 times 10, which is 20. Let's test this. Okay, so then if we change this to plus, we do 10 to the power of 0, which is 1. And then if we say less than 1 here, that'll take us to 0, or that would take us to 1 plus 0 for 1. Now 2 plus 10. Oh, see that? I have count start on 1 and go down. Oh, that was my initial approach, right? But we have to get a length somehow, and we don't want to convert to stir. Right, if we were to start, it would be really easy to do that way, and you could just decrease count, right? But we need to build upwards. This is so frustrating. Why? I just don't know what to do for the case. I feel like this, why is my copy not updating here? $121 less than 1. Okay, I'm gonna take this. All right, we're going to the debugger. Rev is 2. Why is rev 2? Rev is 0, 121. Rem is 1, rev is 0, count is 0. Multiply this. Rev is 1, 120. That might have been it right there. What happened there? 120 rem equals to copy modulo 10. Rem equals to 0. Why does rem equal to 0? Copy is 120. Copy modulo 10. Oh, well, yeah. 120 evenly divides into 10. right? So, okay. So then we have to get, oh, we need to reduce copy by, we need to reduce it down to 12 to get the 2 off. So we have to reduce it by rev, which is 1. Rev. Let's remove count. So we're going to remove count altogether. There's only 1. So you need to take that value. Okay, so you need to take the remainder and multiply it by the base. One, 10 to the power of 1 gives you 1. The remainder is 2, it gives you 10 to the power of remainder. So then the next go would be 2, and then we have to reduce copy down by, becomes 120, and then becomes, oh my, why is this so hard for me, dude? This is like actually really frustrating now. It's getting more and more frustrating the minutes that go by. Okay. So what do we want to accomplish here? We want to say, okay, let's calculate a remainder. That's what we start with, as always. It's equals to the current value modulo 10. Okay. This gives us 121. This gives us 121. Okay, I modulo that by 10. That gives me 1. Okay. I take this value, 1, and I can either multiply it by 10 to the power of I don't need to do powers. No powers. Stop with this power BS. 1 times rev is going to be currently. Rev got updated to 1. Oh, I don't want to update rev to 1. I need to compute a change. Then we can compute the new value. 1. Then we have the remainder. Now we compute the difference. But we don't want to compute that 1 times 10 to the power of. I'm kind of wanting to move on. I'm done with this problem. Tired of thinking about it. This base stuff is so hard for me for some reason. I suck at bit stuff. I suck at base 2, base 10, log stuff. That stuff is. The next one was 21 times multiply the reverse number pair. One times 10 is 10 plus 1 is 11. So current rev. So I do 1 times 12. 1 times 10 plus 2 is 12. The current is 10. 0, add 1. So now becomes 1. On the next pass, rem is 2. 2 times 10 is 20. Plus rem is 2. 2 times the base plus the value, the single value. And then rev would become 21. Oh. rem times 10 plus rem. Right, we have to take the value, the single digit value that we extracted, multiply it by its base, and then add the value back to it. So in the case of 1, we would multiply it by 10. We multiply it by 10 to get 10 plus 1 would be 11. That's not what we're wanting. So let's multiply the value by the current base. Right? So 10 times the current remainder. Okay, so this would be in the first case. But no, in the case of 1, I don't want to do that though. Ten times the is by the reverse sum. Right, by the reverse. So 10 times 0 is 0. Temp equals to base convert plus the remainder of 1 would be 1. And then you just rev plus equals by the temporary variable. We could just bypass that out completely. Do like rev plus equals, it's this. So we take the number, the remainder. I thought we need to take the remainder. Bum, 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 bum. So in the first go, it's going to be 0. 0 times 10 is 0 for the base convert. Let's just... And then we would okay. Copy modulo 10. 121 modulo 10 would give us, write it out here. In the first pass, our remainder would equal to 1. Our base convert would equal to 10 times 1, which goes to 10. It's not what I want to do though, because I don't want to have 10 times 1 equal 10 plus the remainder of 1. That would give me 11. And if I save that as rev, I don't want rev to be 11. I need rev just to be 1. So if I take the that's what I'm doing here. Rev equals rev times 10 plus the remainder. So rev equals 3 in the next room. Yeah, so then we say, and we can just update the copy by just reducing the current copy by 10. What's going on here? Hold on. 121. Q rev 0. Remainder is 1 plus 0. Copy becomes 12. No, we need to not take copy become 12. Copy needs to become times 10. Stuck in a loop here. Crap. 121. Remainder equals to 1. Rev is 0. Rev gets updated to 1. Copy gets downgraded to 120. Can we say copy plus equals just the rev? No. Now we're off. 121 copy remainder rev. Base convert remainder equals to 1. Rev is 1. Copy goes to 120. No, I don't want to take 120. I want to keep it as the 12, so I get the 2 off. Right, because I get the 12, I get the 2 off, and I get the 1 left over. So rather than updating rev as the current, we take the base convert 20 So hold on. So rather than 11. So rather than base convert is going to be 10, remainder is 0. So then if I say this is 10, rev was already 1. Now it would become this is a remainder of 0 though. I don't know what to do with this remainder 0. I don't know what to do with this remainder 0. Get the remainder. We take the current value that we have in there. Take the current value I have in there, which is 1. So let's say I get, do I want to take 120 or 12? 120. If I take 120 and I modulo that by 10, I get 0 for no remainder. So I need to reduce that to 12 to get the 2 out of it. But then I need to take that 2 and multiply it by So I take the remainder, multiply it by 10, excuse me, 10 for the, so 1, 10, 10 plus 11. I don't want to do that. So that's rev 0 times 10, 0 plus 1 gives me 1 for rev. Let me update the copy to 12. Rev is 1, copy is 12. Remainder becomes 2. 2 times 10. This equals 21. Times the remainder. Rev is 0, base convert remainder 1, 121. Rev stays 0 all the way. Crap, dude, I'm really done with this. See, like, why would I multiply by should I just set equal to base convert? Let's be by rev. on the second pass, it's going to be 10. Times remainder plus rev. Why is rev 0? So I'm wrong. No, I have to multiply this by the remainder. Okay, should give me 10 in the first pass. Multiply the Okay, there we go. Okay, so you start at 0. This evaluates to 0, it adds 1. Rev becomes 1. Remainder is 2. 1 times 10 is 10, plus remainder is 12. 12 equals to rev. Oh. Remainder copy, so this goes to 1. 1 plus 0 is 1 for rev. Rev is 1. Right, rev is 1. So we calculate, and then copy is 12. We extract out a 2. Why is 1 times 10 plus 12, sorry, plus 2, this should give me 12 here. What is it giving me? Remainder of 1, 12. Copy is, rev is 12. Oh, and then we're going to get this one and put it right there. Got you. We're going to take the hundredths one now and put it right there. Now we get the copy remainder. It's 1. Copy of 1 here. Add it to rev. It's 121. Because you got a remainder of 1, and you just immediately added this, which was 12 times 10 is 120, plus the 121. Nice. Okay. The walls are caving in. Nice. Alright, MD Explains is getting banned from chat. He did this yesterday and I told him to knock it off. There you go. Sorry, dude. You lost your chance. Okay. Yeah, for real, that guy was annoying. He's clearly like 12, 13. Okay, cool. Did I solve this one already? I want to know. No, I converted to a stir when I first solved it. Okay, so good. I solved it the other way now. Nice. Okay, I do want to, however, do the palindrome stir question and do it without extra space. Okay. So I want to do the palindrome one without extra space. So I don't want to create a slice here. And okay, so we need to use a two-pointer approach. Okay, let's say that start is equal to 0. End is equal to n minus 1, while start does not equal to end. No, while start does not become greater than end. We're going to so we'll have to use another loop here to say while s index of start not equal to, or so while not start dot is al num and not start okay, so let's go. So wait, we have to check all alphanumeric characters, including letters and numbers, and lowercase. So I wanted to run a loop until I get a valid character, right? So while s index of start not, so dot is al num returns a boolean, right? While not and so if it is al num, we're going to lower it. Now let's just do this. So we'll try to create a boolean, right? We'll say while start, while it's not alphanumeric, we're going to continually increase we're going to continually increase start by 1. And then we're also going to do something similar, I think, for the end. So while the end is also not alphanumeric, we'll decrease the end, right? And then these loops will stop, right, when start and end are on valid characters. We'll say if s index of start dot lower not equal to s index of start or end dot lower, we're going to return false, else return true at the end of this entire loop. So what are we doing here? We're going to enter this loop while this is true. So while start is less than end. Okay, so start is 0, end, let's say, is like 5 or whatever, okay? We're going to enter into this loop, okay? We're going to continually also have a sub loop until we get to a character within start for an index value that is alphanumeric. We'll also do that for from the end. Once these loops stop on valid alphanumeric characters for start and end, we're going to evaluate them. If they evaluate to the same, we'll find the next valid set of characters. Right? Oh, I'm sorry. While start less than or equal to end. Or we could say while end is less than start. Or is greater than. Or equal to start. Whatever. Start is less than or equal to end. So start is 0, which is less than or equal to end. When it becomes equal to end, we're still going to evaluate on that to make sure it's the same. Well, actually, I don't think you need to do that while it's less than. Because if you come up to a character that's side by side and adjacent, well, if you evaluate those if the middle characters are adjacent to one another because it's an even length of string, then you evaluate those. If they're the same, okay, fine. Now, you don't need to evaluate when they're on the same index because that's the same value no matter what. So I think this will work. Oh, huh. So used to making my n be the length. Ah, dang it. I always have infinite loops. Well, start is less than end. Continually increase start. Okay, then we have to increase start at the end here and then decrease end at the end after the loop to make it move after doing that check. I'm gonna big balls it, submit. Come on! Come on! Ah. No. Okay. Stream index out of range. Okay, so while okay, so then we have to, it's doing this check No, even if we go out of bounds. Right, we're doing this check while we're going out of bounds. So we have to limit while s is less than the length of Today's a rough day for me, boys. We were doing good yesterday. Boom, 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 boom. 105 in Boston. Curious. Mom's answering a text here. Okay. Okay, so let's get back to this. Okay, so we have an index out of range. Okay, so it's right, it's the start condition is being hit here. Okay, so we want to say, I think we just basically need to say right? The start can't cross over the end or else you go out of bounds. And so here, we just say the same thing, because if start is ever greater than end, then we don't want to do this. Hey! Okay, that was it. So we just had to limit the start from, like, kind of overload it, right? Boom, 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 boom. Hey, what's this guy over here? I and j equals 0 length. Oh, it's the same thing. Tried it with a regular expression. Okay. All right. Do we do a rando? Which one should we do? Any easy ones we can do? Should we just rando it? Array wrapper. Oh, JavaScript. Oh god. I think Tim wanted to do a threesome. You there, Tim? Mr. Tim. Let's do this. Right. Oops, sorry. Okay. Okay. Given an integer array of numbers, return all the triplets such that j is less than I is less than j, I is less than k. Oh, that they don't equal one another. They're all unique numbers, and that they all add up to 0. Notice that the solution set must not contain duplicate triplets. Okay, so we're doing this one. Okay, I've never done this one before, so let's give it a try. Okay, so we have to figure out 3 numbers within this array that all add up to 0. Oh, you have to output all the possible combinations too. So okay, so we need to pick 3 numbers in this array. Three numbers in this array that all add up to 0 and that are all distinct. So honestly, I have like really no idea where to start. So distinct triplets does not matter. So I don't want to use O of n, right, to just, find all the possibilities on every single value. That's not what I want to do. So what if I keep like a running? So like, I go through the array. I don't want to repeat work that I've already done. So I need to, if I start off on 0, 0 with like 2 and move one forward. So how can we do this? Was there like a desired time complexity? This is Notice this. Okay, so where do we even begin? So if I have -1, right? If I have -1 and I want to obviously we need to correlate it and save indices. I mean, you don't want to sort because then you lose your indices, but if you sort you get order and you might be able to better kind of flutter around as the zero value or where zero should be within those, if it's even possible. The only solution that's coming to my head is just O of n squared, where you check every value of n for every value of m. But then you have to identify a third point, right? But once you've already seen a point, it's gone. So like, and then move the index forward. So if you save the first value and start at 2 and 3, but then you'd have to move, that still would be O of n squared because you'd have to move j through the loop and then I one forward. But then you'd have to do that for every single, that'd become O of n cubed. Because then the one that you have on the outskirts would have to go through all the ends. Your initial pointer would have, your starter pointer, dude, we're cooked. We're cooked. It's already 9 o'clock. Ugh, God. I haven't even wrote a single thing of code yet. No idea where to start. Triplets. No clue. I think we might move on. I got no clue. This is not helping us just sitting here. We gotta practice some stuff. I'm not gonna look it up. I don't want to look it up. I don't want to look at any hints either. I'm stubborn. any number of times possibly 0. Oh, that just looks too complicated. I'm not gonna do it. Okay. Given the root of a binary search tree, return the minimum absolute difference between the two values of any two. Get minimum difference between the values of any two different nodes in the tree. Given the root, return the minimum absolute difference between two, one. So that's right. Function here. We're given a node. Let's see. Minimum. Call helper node. Say if node done. That's right. It's called this. So we're saying if, so say left diff equals to node dot val less than left diff equals to absolute value of node dot val less than node dot left dot val. Let's call this for right as well. Right, this might equal none, so we'll have to say so if you don't have a left but you do have a right, if you don't, if node dot left and not node dot right, we're gonna call just node just on left diff. Right? If node dot right and not node left, we're going to call right diff. Right? So I do the left call and then I move root or node equals node dot, I'm gonna call helper node dot left here, and then I'll call helper node dot right here. If left and not right, if right and not left. let's do this. Right, if you have both of them, you go here, no matter what you call the next node. If right diff let's take the min. So this is gonna be the step. Min is equal to the min between left diff and right diff, and say we'll say actually minimum is equal to the min between left diff, right diff, and we call helper node left, node right. Okay, so if you come to a leaf node, you return. If you have a left and not a right node, you just call left diff on the, you just calculate out for the left node at this point in time. If right node and not left node, you just call it for the right value. Else you call it for both, and no matter what you set the minimum here. I don't know if you can set as a none object. Because in some of these passes it might be none. Right? I don't think that this is going to work. So if we call helper on root, we're not returning anywhere though. This here. Just returns and ends. So then we want to return so if I call so I have to go like what's the thing? What's the decorator for like a with not node and return drawn a leaf. First So left subtree. Let's recurse the left subtree. So then if we need to define any two differences, yeah. Okay, so then we'll say we'll travel the left subtree. So we'll travel the left subtree, right? But we need to keep track of the previous node visited, right? So if we come to a node that's blank, we're going to return nothing. Else we'll call helper on the left node. We'll say if there's a previous node, I'm going to say previous.value if previous value if previous diff is equal to node.val right, we'll call min it's going to be equal to the min of diff and minimum. We got helper. Right. No. But if I have previous node is equal to previous, oh, so we'll just say previous, let's just say previous value. Previous value less than the current node value. Calculate the minimum and set the previous equal to, or the previous value equal to node dot value. you can do this in Python? Right, so it's trying to access this minimum value here. Has to be some very large value. So let's just set this immediately to node.val or root.value right off the jump. No, we don't want to. We need it to be some arbitrary large value at the start because we have to reduce this down. Unless I pass it with me. Hey, Bizwyan. Yeah, I think it's between parent and child. So if I set it to float infinite, right? Is this inside the function or outside? So do I have to put this inside here? No, I want it to... No, I don't want it to update every time I call this function. So how can I define this minimum as is local? What's that thing you can do? I forgot. What's the thing that Python has? What is the is local decorator Python has for declaring non-local? You can call non-local on minimum. Maybe not. But you just have to define it. Right? You probably have to define like you do global first. Dang it. agree. Not on the root call here. It'd be none at the start, right? Yes. You guys did the rear you call right. Oh, that's right. You could just access it with a self call to this class of minimum. Right, and then I have to just call self.minimum here. Self.minimum. This isn't gonna work for this test case though. Oh my gosh. So many bugs. Self.minimum. Okay, still getting this one wrong. I think it's because we're passing in. No. If not node, turn node. Call in or help on nodes. So let's just remove previous value. Function. So we have to move this to happen all the time. And then we got it. Come on. So many edge cases. Right. The minimum value difference will always be between minimum value and the tree that's not none. Why am I having issues with this one? Why am I having issues with this? Oh. It's this right here. So we have to specifically say is not none. Because 0 it also evaluates to truthy, falsy in Python, right? So I think that'll do it. Okay, so BST, you go left, evaluate on the node, go right. Okay, BST, you exhaust until your node is none. For your base case, you traverse left, you calculate on whatever your condition is for your node, and then you traverse right. Okay. You're given a list of strings, logs, and log index I is the operation performed by the user at the ith step. The file system starts in the main folder, then the operation performed. Return the minimum number of operations you need to go back to the main folder after the change. I don't even want to read this. Come on, give me a... Stop giving me like a word problem. Give me a coding problem. Okay. You're given a string where every 2 consecutive vertical bars are grouped in a pair. In other words, first and second bar make a pair, third and fourth bar make a pair, and so on. Return the number of stars in string, excluding the stars between each pair. Okay. So this isn't that bad really. Let's just keep like a flag then to determine if we're open. So open flag, open bar equals to false at first, let's go for char in S, if char is quote, so let's say, okay, if the char is equal to a bar, a vertical bar, and if open bar, we're going to set open bar equal to, oh, so if not open bar, we'll say if not open bar. All right, if not open bar, meaning that this is, we're going to set open bar equal to true. Okay, else right, so else, okay, if we come across a bar and the open bar is in true, we're going to set the open bar equal to false. Okay? Okay, if it's not a bar character, if it's not a bar character, if not open bar, meaning that we can make count, we're going to say count is equal to 0. Count plus equal by 1. Oh, else just okay. So what is this saying? So if we come across a bar and our flag, right, for indicating that we are currently within an open bar is false, then we're going to open the bar. We're going to open the flag, raise the flag. Okay, we're open, meaning that we can't count characters. Else, if we come across a bar that is true, then we're going to set it to false, meaning that we're closing this section, and then we're going to mean that we can make counts. Okay, if the bar is not open, then we can increase counts on these iterations. And so if we can just return count here, so if it doesn't equal to a char, so if it doesn't equal to a char, we'll do this. I thought we hit this continue here though, so I thought that takes care of it. Oh, it's counting every character? Oh, it just wants asterisks. My bad. Sorry. If else, elif, char is equal to an asterisk, right? If the bar is not open, we're going to increase the count. I always have so many typos with Leet code. Here we go. Nice. What's this song? Oh, well, I'm probably gonna hear the copyright strike for that one. Shoot. I'll have to cut it out of the stream. I'll take my solution here. Right, if the char is equal to a bar, open bar. So we could say this and not bar. We're going to increase the count here. Such. That'll still work. So there's this interesting thing you can do in Python. So for this statement here, you could just say, so if not open bar, so to set the flag, you can just say this, open bar equals to not open bar. Interesting. I didn't know you could say that. It's a clever and concise way to toggle a Boolean value between true and false. Every time you hit a bar, you want to flip state. If you're outside of a pipe section, open bar equals false. Encountering bar brings you inside of a pipe section, so open bar becomes true. This line is equivalent to if open bar equals false, else open bar equals true. Open bar equals not what open bar currently is. Okay, that's interesting. So I didn't know that you can say this. So if you guys see here, you can say set open bar equal to not whatever open bar is, Boolean wise. So if Boolean open bar is true, set it to not true. Or like toggle it not true. If it's false, set it to not false. That's a cool way of doing that. That's really cool. I like that a lot. Okay. Yeah. Not gonna have it. Okay, longest happy string. A string S is happy if it satisfies the following conditions. Only contains A, B, C. Does not contain any triple A's, B's, or C's as a substring. Contains at most A occurrences of the letter A, with B occurrences of the letter B, and C occurrences of the letter C. Given three integers, A, B, and C, return the longest possible happy string. If there are multiple longest happy strings, return any of them. Oh. Okay, so we would have to recursively call, and then if you meet a condition where you have no values left between A, B, and C, then you append that string. Okay. So could we call, say, def helper given an A, a B, and a C? Okay, so we'll say our base case, if not A and not B and not C, we're going to call self dot found or valid dot append the string and then the current string that we're on. Right? But you have to generate these strings, right? So we would need to if not A, not B, and not C, then the valid string we would append. So you can't have these conditions. You can't have triple in a row. Okay, so we'll say I'll append the valid string. Okay. We're going to call if triplet okay, let's do this. Okay, let's call it. Let's add a letter. Okay. If A, we're going to take string plus equals quote A, right? If A, we're going to take string and add A to it, and we're going to reduce A by 1, right? And then we're going to call helper string A, B, C. If B, I'm basically going to do the same thing but for B and C. So if B, we'll do the B here, B minus and C minus. C. Okay. You do like a okay, right? So if A will call helper, if B will call it, and if C will call it on there. You append the valid string if you run out. But once you add a letter, we need to call a check triplet here. If not, check triplet. So we'll call triplet on the string. But can I keep track of an index? Let's say let's keep track of a self.index is equal to 0. Let's call triplet on string index of 0, or on string of this index. And we're going to add the string. That'll access the index of 0. And then let's increase index by 1 here. So if not, so if triplet evaluates back to true, then we're going to return. This is not valid. And then we'll increase the index only if it's non-valid, if it is valid. So then let's take index, bring this down here, because it'll apply to all of them. So if triplet return if triplet, we're going to return and then increase the index. Okay, so if we come to a point in time where we have no more A's, B's, or C values, then we're going to append the string. Okay. If there is an A value to be placed, we're going to append the string, call triplet. If it is, if that value is to true, then we're going to return. So let me call a function here called def triplet. Where we're going to be putting in string and index. Okay, so I'll give in a current, just an index. Okay, given an index. So I'm going to say try to say that left equals to string string index of index here less than 1, the middle current will be here, and then right will be index +1, except for a value or a index error, we're just going to return false, right? Return left equal to current equal to right. Can I do it like this? Then if I call helper on a blank string, A, B, B, and C. So we'll have to have self.valid. So a list. Return self.valid index 0 if self.valid, else none. I have an interview on Thursday. For a software engineer chemist position. Okay, so helper string A, B, and C. If not, we're going to append in the string. If triplet comes back as true, return. Okay, so then if I say, okay, so let me self.index. Alright, I'll put here. Let's just feed in the return string. Typos. So this is giving me triplets back. Why is this giving me triplets? Quadroons a lot. So if triplet, we're going to return. What if I just break? Oh no, just return. So if triplet, return left. If left equals right. Now I'm calling triplet to evaluate the current indexes of the string, right? So when I add a value, I check to the left and right and see if those values right? I say if left and right. I want to see. I want to get a hint here. See if we can get a hint. Oh, hold on. So I don't want to say self-index globally because okay, so let's instead get rid of this. Let's just focus on A. So if so if the string so if the string up to the negative first is equal to string to the negative second, which is equal to char, but you also have to make sure you have the available indices, right? So the length of string, you have to have at least 2 characters. So if it's this case, then we're going to return and then call one. So we say longest valid equals to 0. So if string say while a, add a, calculate the length, and return. So wait to A, B, and C, while A. So then do we just do this for B as C as well? No, you wouldn't want to do A. I'm not sure. I suck, dude. All right, I'm going to bed, guys. I'm tired. I'll see you guys tomorrow.